Good day, everybody. My name is Mitch Simon. I'm with the IBM Industry Solutions team focused on IBM Energy. So that's oil and gas and energy and utility companies. Today, I'm going to take you through a presentation on leveraging data and AI in asset management. I've spent the last 8 years working with utilities on their data, AI, and automation initiatives. So this is a timely topic for all of our utility customers as they innovate for the energy transition. I wanted to start off with kind of an industry perspective of some of the key challenges that we're seeing across the utility landscape. Starting with asset operations, many of the grids that are in production today have an aging asset infrastructure. And this is complicating safety and reliability because not only are assets aging and subject to failure, we also have a transitioning workforce that has tribal knowledge and is taking that knowledge with them as they seek to retire. At the same time, we're seeing the grid under threat from extreme weather events. This is not only storm events such as hurricanes and so forth, but also wildfires. More and more, we're seeing wildfires threatening the disruption of utility operations. Moving over to energy systems, we're seeing a desire through environmental, social initiatives and policy initiatives to increase the amount of renewable energy in the grid. And so we're all familiar with the energy transition and the goal to decarbonize. But there's a conundrum in place. As we increase the amount of renewable energy, which is intermittent, we're also going to see an increase in demand, primarily driven by the electrification of transportation and buildings. On the customer side, there is also a transformation taking place. Customers want a more digital experience with their utility. Similar to what they're getting from banks and from retail organizations. So they want more of an intimate engagement with the utility. They're looking for sustainable options, things like smart home efficiency options. For example, appliances and pool pumps. They're also asking questions about renewable energy. How do I get solar panels put on my roof? Can I get a electronic vehicle charging station installed at my home? And so they're looking for more proactive and personalized interactions. And as the more complex questions come into the call center, utilities are still looking to optimize customer care and to reduce agent handling time. Finally, across the enterprise, we're seeing the usual pressure to increase operational efficiencies and reduce cost. We're also seeing an increase in regulation, right? As we bring more renewable energy onto the grid, there are regulatory frameworks that are coming at us very quickly. And finally, and it's not listed here on the chart, I do need to mention cybersecurity. Cybersecurity is front and center for every utility, regardless of the domain, whether it's gas, electric, or water. So how are utilities responding to these challenges? I'm seeing 3 key digital trends that support the energy transition. It first starts off with digitizing the assets. So using more machine data, putting sensors on existing infrastructure, or deploying new equipment with sensors already built in that broadcast data back to the utility. And so the utility is using that data to understand the reliability and the resilience of the asset infrastructure, and leveraging machine learning, right, to optimize efficiencies across asset operations. We're also seeing digitization of interactions both with customers and with employees of the utility. And what they're doing is they're implementing conversational AI with natural language processing in order to create a more valuable experience. From a workforce perspective, utilities are using conversational AI to improve their efficiency, to improve productivity, but also to improve worker safety. On the customer side, these digitization trends are really focused on a mobile experience, being able to implement a chatbot, for example, for customer interaction, service, and support. On the grid side, and this is probably one of the most transformational opportunities, is really around how do we accelerate and orchestrate the integration of distributed energy resources, primarily wind and solar. And so the challenge here and the way utilities are addressing that is to implement exogenous technologies such as artificial intelligence, machine learning, and optimization in order to deliver the energy to the consumer location at the right time. And making these decisions in near real time is critical in order to scale the integration of renewable energy. I'm now going to take you through some use cases that we're seeing and how utilities are leveraging these advanced technologies in order to improve their operations. In the first use case, we're seeing a trend to enable AI and edge computing for remote inspection and monitoring of the infrastructure. So imagine you have a substation out in a remote location. You have a gas compressor stations in remote locations. You have water pumping stations in remote locations. Today, the strategy is to get a crew, roll a truck, and do an inspection or to capture readings from the meters. And what utilities have figured out is in order to help them achieve their ESG goals, enabling the remote monitoring of this infrastructure allows them to reduce the cost of truck rolls. And leveraging communications technology, they're able to bring that data back into the into the data center, and to do analysis on the data to improve worker safety, asset reliability, and so forth. And edge, I want to make one comment about edge, which is that with edge computing, you don't need to bring all the data back into the data center. So edge computing allows you to run those artificial intelligence or machine learning algorithms where the data is collected. And that also reduces demand on the communication infrastructure. We're also seeing, and this is sort of been a trend for the last 6 or 7 years, combining multiple data sources. So machine data, inspection data, weather data, IoT data, and work order data, and applying artificial intelligence and machine learning to understand the health and risk of assets. And this is transforming operations and maintenance teams to be more proactive in understanding the asset reliability and prioritizing the work that needs to be done. And ultimately, this is improving grid performance, increasing reliability, and extending asset life. We're seeing a huge uptick and a demand for conversational AI to guide field technicians in their operations in the field. This could be for engineering and construction. It could be for repair. It could be for inspection. But the idea here is to make every field worker the best worker possible. And we do that through reducing the mean time to repair, improving safety, and increasing their overall productivity as they conduct their work. I want to take you through some solutions that we have in the Maximo application suite. I want to first start off talking about asset performance management. And there's two capabilities where asset performance management, leveraging data to make decisions about what I call the 3 R's: repair, refurbish, or replace. There's actually a fourth outcome, which could be to put that asset on a watch list. So the two capabilities, the first one we call Maximo Monitor. It's an active monitoring solution for distributed and remote infrastructure. All right, so we're collecting machine data and we're applying machine learning and statistical analysis in order to implement predictive maintenance frameworks or even condition-based maintenance. This solution has embedded AI anomaly detection algorithms. You can also add your own algorithms, so that's a nice feature as well. That helps utility workers understand root cause analysis associated with equipment degradation. We have an IoT connection service embedded, and we also enable edge computing as we're able to push these algorithms down to where the data is actually being collected. We also have a more traditional asset performance management solution. It's called Health and Predict for utilities. This solution understands the health and risk of assets in transmission and distribution. So it's optimized for T&D, electric. We support standards, IEC standards 61970 and 61968, which makes up the Common Information Model power systems. We have out-of-the-box models for key assets in the T&D grid: transformers, circuit breakers, poles, underground cables, overhead conductors, switchgear, and batteries. These algorithms include health scores, criticality scores, what's the probability of failure, which also includes a list of data points or SCADA readings that indicate what's making up that probability of failure. So that's an important avenue to understand root cause analysis. We also calculate the risk score along with effective age, and we have some data reliability and data integrity algorithms to ensure that when the reliability engineer is looking at these scores, they can trust the scores based on how good the data is. The Health and Predict for utilities does drive maintenance prioritization and replacement planning. And utilities are moving to a risk-based model, okay, in terms of prioritization. So only focus in the short term on those assets that have the highest risk associated with failure and health. I want to take you through some examples of how other utility clients are leveraging this technology to improve and optimize their asset lifecycle operations. In every case here, we're seeing data-driven approach to maintenance. In this first example here with a European energy provider, we did a project with them to do predictive maintenance on turbopumps. Their business challenge was associated with unplanned downtime or shutdowns or performance degradations that impacted their generation contract commitments. We did focus on turbopumps. That was a key challenge for them in their generation plants. The solution included calculating health scores along with failure probabilities, but also a metric on days to failure. We were also capturing anomalies based on SCADA alarms and alerts. And based on the anomaly accounts, that would also trigger, for example, a work order to do an inspection or to do some sort of repair action. The tool also served up prescriptive maintenance recommendations, so the technician was well aware of exactly what they needed to work on. At Red Electrica, they have a project that's been in production now for 3-4 years, called Intelligent Maintenance for Substations. So in their transmission network, they were highly focused on optimizing maintenance actions for the substations. They were doing more of that time-based approach, leveraging the health and predict for utilities. They moved to more of a reliability-centered and risk-based maintenance strategy. They've seen tremendous return on investment. They've achieved 10 to 30% reduction in maintenance and replacement costs and 15 to 40% labor hour savings across all their asset management processes. What's wonderful about their solution is they're using a business rules engine from IBM called Decision Management in order to drive prescriptive maintenance actions. And what this allows them to do is to reduce the number of meetings, the number of discussions that have to happen on what to do next, right? All their maintenance policies have been codified in this rules engine. So they have quicker time to action, which allows them to achieve the kind of savings they're getting. Finally, over here on the far right-hand side is Melbourne Water. They operate in Australia, and their challenge was remote inspection of stormwater grades. So they have a very vast territory, more than 14,000 kilometers. Much of that territory is in remote areas that are deemed dangerous because they're out in the Australian bush and jungle. And what they've done is they've deployed some fixed cameras out at each one of these stormwater grates, attach them to a 3G network, and they power the cameras and the communications links using solar panels. And what they're doing is they're capturing anomalies associated with garbage or other debris that may be collecting at the stormwater grate. And they're using a deep learning visual inspection tool from IBM and a monitor, right, to flag anomalies where debris are starting to block the stormwater grate, and then they'll roll the truck. And so what this is doing for them is it's allowing them to reduce their in-person inspections, reducing carbon emissions associated with truck rolls, and being able to move quickly to a condition-based approach, keeping their workers safe and only sending them out when they need to. Another important use case that we're seeing is the visual inspection. So IBM is a leader in visual analytics technology. We have a best-in-class solution associated with a visual inspection. We're automating the process of taking the images, ingesting them into a point-and-click tool, right? So the images could come from a helicopter or a drone or field inspector using their tablet or camera, or also from a fixed camera. And in fact, fixed cameras are becoming more common in the substation for a variety of reasons. I'm also going to share a use case here in a moment where we're also using robotics to perform inspections. But what's important about the visual inspection tool is that you do not need to hire a data science to identify anomalies in the visual images. So we have a point-and-click tool for labeling and training these models. We will provide that to the line of business who will train the models. And then as the pictures are coming in from the remote locations, we're able to flag those that have anomalies. And what we've noticed and what we've seen is the opportunity to do more inference at the edge. So the tool does come with the ability to run the model right on the camera itself, whether that's a fixed camera or a mobile camera. We integrate the outcomes with work and asset management processes. And this also reduces the need for in-person inspections and increases worker safety. And you can see there's a variety over here on the right, a variety of anomalies we can detect. I've just captured a few here. Hot spots or dead spots on a solar panel, broken porcelain or damaged conductors, hot wires, which is an example of where we can improve safety outcomes. Here is a better breakdown of visual inspection use cases across the utility landscape. I'm just going to mention a few here. On the generation side, I just talked about flying a drone, for example, over a solar farm and identifying hot spots or dead spots. We're also seeing a lot of use cases for wind turbines and wind towers. In order to inspect the structural integrity of those towers, as well as the blades. Blades get damaged all the time from hailstorms and from birds and all kinds of debris. And so identifying defects in those blades is a critical use case associated either with warranty or insurance claims, but also with production, right? With energy production. Another interesting use case, if I'm looking now down here at the stack and dam inspections, is cracks in concrete. And so we're able to not only identify and classify cracks in concrete, but also to look back and be able to see if the cracks are growing or not. On the transmission side, I talked about the broken insulators and conductors. There's also this notion of rust and corrosion on these towers, and also environmental hazards such as birds' nests that we tend to find on these transmission towers. Visual inspection can also feed insights into your vegetation management programs. It can also investigate line sag as well as man-made encroachments. On the distribution side, similar to transmission, but also there's some additional use cases, especially in the substation, looking for damaged equipment or flash connections, and also looking for animals that tend to find their way into the substation. And one thing that I want to mention is also worker safety. So we can mount a camera on a truck and observe, are workers wearing their PPE? Are they wearing a helmet? Are they wearing a safety vest? Do they have their gloves in order to ensure that they're properly equipped for the work they're about to perform? Visual inspection also. IBM has made available a set of accelerators on the digital twin marketplace. I have a link down here at the bottom of the slide. I encourage you to go out and investigate all the digital assets for Maximo. There's 3 sets of models on the exchange. They're at no cost. You can download them. You can ingest them into your visual inspection deployment. But I wanted to highlight that they are available. They're starter models. It's work that we've done in other projects. So we can get you up and running fairly quickly for these 3 use cases. One is to detect PPE for workers, safety, analyzing sedimentation in tanks for cleanliness, and then the various use cases for a transmission tower, looking at conductors, looking at dampers, gas insulators, and so forth. Again, these are all available on the Digital Twin Exchange at no cost to customers. Here's some innovation that IBM Research is teamed up with Boston Dynamics. Boston Dynamics has a robot dog. It's called Spot the Robot. And we're working with National Grid here in the US for innovation in leveraging Spot to do remote inspection. So the way the use case works is, Spot will has a LiDAR sensor and will go out and map the territory. In this case, it's a substation. So we'll train Spot on what the daily mission is. Spot will then do its unattended inspections automatically, right? So it walks around the substation, it can walk up and down stairs, the camera can move in all different directions. It also can be outfitted with additional sensors, like gas sensors. But we have a thermal imaging camera on there as well. And Spot does its mission, it walks around and collects data. And it's collecting all the data. And that's one of the outcomes that we learned is it's capturing more data than a human might. And what's also interesting about this use case and one of the innovations is that Spot is able to read an analog gauge. And that is very, very interesting because, a lot of these gauges have dust, they have dirt on them. Some of them are easier to read than others. And we've done a lot of work to train Spot to build algorithms to read the analog gauges. So very cool stuff, along with thermal anomalies. And look, Spot can be deployed anywhere in your utility operations. Plants, inside or outside a generation plant is also a potential use case for Spot. Another use case that Maximo offers is Maximo Assist. So this is worker assistance, enabling or leveraging AI to enable the utility field worker to perform their work with expertise, right? So not every field worker or every utility worker has even expertise. We have some folks, right, that have 30, 40 years experience. They're also beginning to retire. And then we have the younger workers, the newer workers coming in that don't have, maybe 2, 3 years experience. So leveraging conversational AI by aggregating both structured and unstructured data. So you can see here on the right-hand side, we've got a list of data sources, and these are just some common examples: engineering and equipment manuals, historical work order information, regulatory standards, which is important, by the way, in engineering and construction, but also in maintenance and repair. Standard operating procedures. Safety procedures is another challenge. In terms of dissemination, how do you get those safety procedures out to hundreds, if not thousands, of field workers, potentially contractors? And so this tool enables the dissemination of information. We also collect sensor data, SCADA data, fault codes coming off the equipment in order to query the Maximo Assistant to serve up in advance, for example, recommendations on repair, on diagnosis and repair. So the two use cases is equipment diagnosis and repair, but also technical search, right? Using Watson technology. Another important capability of this solution is that it can integrate with any of your mobile investments. So you could be using Maximo Mobile, but if you're not, if you're using a different mobile solution, we can connect to that. We can also enable guided repair and technical search through a web browser. The solution brings expertise to all of your workers. So we're addressing challenges with the aging and retiring workforce. We're addressing challenges with siloed and tribal information. And we're addressing challenges with disseminating the latest guidance and procedures to the workers. And so the outcomes that we expect to see from worker assistance is improving the worker productivity, boosting first-time fix rates, reducing troubleshooting time, and reducing training costs, and ultimately reducing operations and maintenance expense overall as it relates to repair activities. Again, this solution is being widely deployed across the utility landscape. I've just highlighted three examples here. We have a a partnership with a service provider that provides services to nuclear plants. In this case, their challenge was access to repair procedures and technical documentation, which resulted in a mean time, or I'm sorry, resulted in extended mean time to repair, in this case for a refuel machine. And so we provided the client here a conversational AI assistant that served up troubleshooting tips, repair recommendations, and step-by-step instructions. They've ingested, common equipment specifications and repair manuals along with their specific maintenance policies and procedures. Here in the middle column, we have an Italian energy company, so based out of Italy. They had a requirement or a challenge on how to improve how they operate and maintain a steam turbine. So they had a workforce that wasn't skilled completely in the operations and maintenance of these steam turbines. So they also fell into what I call the knowledge gap, right, where workers have left the workforce and the new workforce is just not up to speed as much as they would like. So we provided them a virtual assistant, all based on the Watson AI technology, so they could interact through a conversational AI interface by posing questions regarding operating and maintaining this equipment. We also ingested, in addition to engineering and technical documents, we ingested fault codes, right? So this is that use case where we're, when we see a fault code, we pass it into assist, and assist automatically comes back with recommendations on what to do next, right? So based on the current state or current condition of the turbine. Another thing I want to point out is the ability to ingest and analyze and serve up system drawings and equipment specifications. So this is, we can work with text, but we can work with images and system drawings as well. And then finally, over here on the far right is Woodside. They're one of the early adopters of this technology. And just to give you a sense of their operations, we ingested more than 600,000 pages of documentation. So that's a lot of documentation. We helped them reduce research time, which made up 80% or almost 75% of their effort, right? So by having a technical search, an AI technical search, they're able to get to answers very quickly, right into the correct passage within the documentation itself. And so they saw a labor savings upwards of $10 million US. So tying this all back to Maximo and the Maximo application suite, today I spoke about Maximo Monitor, which is that active monitoring solution, leveraging live data or near real-time data in order to detect anomalies, to understand the condition of the asset, and to raise an alert so that somebody can take action, and seamless integration into Maximo Manage. Health and Predict for utilities. This is providing that health and risk analysis that I spoke about earlier, along with asset investment planning. And this is enabling organizations to move from time and calendar-based to more of a risk-based approach. Visual inspection is, again, a best-in-class tool for analyzing anomalies that we detect from images that we capture, whether they're fixed cameras or cameras on devices such as phones and tablets, but also from Spot the Robot, as well as from drones. And then finally, over here on the right-hand side is Assist. This is that prescriptive guidance and assistance that we can give to any field worker or any knowledge worker within the utility. All of these solutions can coexist with your existing Maximo footprint. So you do not need to be on Maximo application suite in order to leverage this technology. And we're more than happy to support your transition to a data-driven approach. We can deploy this in any infrastructure, whether it's on-prem or in the cloud. And we have a managed service if you'd like us to manage the solution for you. I wanted to close out with some third-party analysis from IDC. So IDC is one of those analyst organizations. They did an analysis across different industries. So this is not specific to energy and utilities, but across the Maximo user base. And they wanted to understand what's the business value of IBM Maximo. And so coming out of that analysis, I wanted to share what a data-driven approach to asset management could bring to your organization. IDC identified a data-driven approach results in 43% less downtime, so almost half a reduction in unplanned downtime, a 28% increase in user productivity, and on average, a total equipment cost avoidance of $8.6 million. And that cost avoidance is primarily by leveraging these data and AI technologies in order to extend asset life. And that is all I have for today. Thank you for your time.